I'm CK. In the last little while I've built a couple of Tesla coils. You can see the videos on my channel. So I wanted to do a different kind of high voltage treat. So I got a Jacob's Ladder kit. Now Jacob's Ladder, you may recall from old horror films, is the two wires with the spark riding up the gap. So it's hard to find them, and this one actually was probably one of the pricier kits I've ever built on the channel, not counting Eurorack, I mean general purpose kits. This comes in at like $60 some US, and you also need to provide your own DC power supply. So I bought this from jamco.com. I will try to remember to put a link to this in the video description. If I don't, please leave a comment saying you forgot again. This was about $23. So total of about $80 for this. So we'll put it together and see how it goes and see if it's really fun. I do want to add an additional comment to this video. This video has more high voltage accessible to you than normal. The Jacob's Ladder takes a good bit of voltage to get the spark going up the gap, and if you go and have to buy your own power supply, you'll probably have to hook it up to mains voltage yourself. So please do not do this unless you're really confident working with high voltage. It can hurt or kill you, so be very careful. But other than that, I hope you enjoy the video. Here's the box. Mini DC induction, Jacob's Ladder, high pressure, R something or other, made in China. Okay, we got this in shrink wrap. We've got this is solid core copper wire, which I assume we'll make our antenna with. Something there, and something random bubble wrap, and it looks like a base and some feet and stuff. No instructions. I bet they're on the Amazon product page, so I'll look that up in a little bit. Now we'll get the box ready for recycling. Let's see what we got in here. Here, inside more bubble wrap, inside a bag that I tried to cut open but not working. We have, okay, this is all pre-made. I'm not soldering any of this. Looks like, so we're going to put in here 12 to 24 volts. This looks like two big capacitors, a choke or a transformer. I think it's just a choke inductor. Two really beefy caps for, I can't read the color bands. I can't see what that second one is. I think it's violet. 4700, so 4.7K ohm. Then a couple of diodes, really beefy voltage regulator power transistors, and a couple more diodes, and this is the output side. 3 terminals. What do we got in here? Looks like we got a big old, I'm not sure what this is. It feels like, okay, a big old pumping transformer. Oh yeah. Okay, we're going to take, this has got one small conductor inside. This looks like almost like an ignition coil, but it's definitely the output coil. Oh, look at this. It's got two terminals, two rotating controls, focus and screen. So this came out of a television or video monitor of some type, magnetic generating stuff. So this will be, these are the primary and secondary coils to fire off the energy going to the coil itself. And then, yeah, here, this is simply a Lexan plate, some feet, and some heavy-duty screws and so on to set it up on. So that is not much. We're going to, I'm not sure how this is going to, oh, I see. I think I see. We've got three, well, see, now I'm confused again. We've got 4 wires here and 1 wire here with this also, which this should go to the copper wings or antenna, whatever you want to call them. And this I don't like. I'm going to put some shrink wrap over that. You can see they just nipped off that other piece of cable and didn't cover it up. I'm going to cover it up. But I've got 3 outs and 4 wires. Let me take a look at this one. I think this will get the power from mains right here. Oh no, I'm sorry. Oh yeah, I guess. Yeah, I'm sorry. This will get the power from the 12 to 24 volt power supply. It'll put it out here, and I'm going to assume that these are the ones that will go in there, and then these go to the antenna. So let me also open up the power supply I got to pump power to this thing. As I mentioned, I got it from jameco.com. I will try and post a link, but I often forget. So, line in, AC, not grounded. Oh no, there's the ground. And then 2 voltage taps for the output, 2 for negative, 2 for positive. Voltage adjust so you can set it to what we want. AC voltage can be selected by switch. Check the input voltage. Yes, I agree. See, because right now it's set to 240 volts. We don't want that because I'm in the US. So I had to switch to 115. So be very careful if you get one of these. I'm not going to take this apart. If you want to look at power supply teardowns and so on, go to Diode Gone Wild's channel. He's got very good power supply teardowns. So this looks fine. Again, this costs 23 bucks, something like that. And yes, I will have to wire up mains voltage to these 2 terminals, and as you can see, they're not covered. So again, if you're not comfortable working with that, please do not do so. So that is the very limited number of parts that are in this kit. And we'll see how it goes together and then see how it fires off. I will be looking up the build instructions from their product page, and we'll show you after we get everything set up. I went to the Amazon product page, and the instructions are 1, 2, 3, 4, 5, 6 pictures. So there's not a lot. So we'll see what we're going to do here. First thing we're going to do is I'm going to take the plastic film off of this, which is always fun to watch, so I'll probably cut this out. I should have done this off camera, but I didn't, so there's that. dump these things out here. And I can't even really see what the heck you're talking about. These two big screws are for the insulators. So I guess these little Allen head screws are going to be the feet. Now we're going to put the insulators on. That's good. Now we're going to take the copper wire. This is not braided, this is single strand. Try and bend it equally in half. They don't give you an indication of how long you should make these. So I'm going to just cut it in half and go from there. Now we do have to take all the insulation off these wires. So I will get a X-Acto knife, back in a flash. Let's see, if I pull a good 4 inches off it, can I peel it all the way off? Probably not, but I'll give it a try. Nope. And I got the wrong blade in here. Let me go switch blades real quick. So what we're going to do is we're going to bend one end. Actually, first thing I'm going to do, we're going to be putting this around this screw. So we have two choices. We can simply wrap it around the screw, which is kind of tough because this wire is really thick, or we can bend it with some bending pliers, which you can use if you don't have bending pliers, which many people don't. They're kind of a luxury specialty item that I don't really need, but I wanted them. You can use needle nose pliers for it too. Can I get the screw through that? That'll be good. Even though I can see I'm going to need different screwdriver. Hold on. So we've got that there. I'm going to bend this a little bit in now that I've got it around the screw. Now it's going to go in, it's going to face inwards, about like so, because the two antenna conductors need to be facing each other. So I will screw this down really tightly. Give that a good squeeze. Now I'll do the other wire, and I'll cut the cameras for that because you've seen me do one. You don't need to see me do two. Actually, I had already cut that one. Stripped this one. You should have reminded me, guys, because I turned the cameras off for no reason. The other screw in there. Hold on 1 second so I can see what I'm doing in the future here. Oh, I'm going to have to put I shouldn't tighten these all the way down, because I'm going to have to put the leads from the coil on. Okay, so that's that done. And the 3 wires of the high voltage packet are connected to the output end of the circuit board in order, and tighten the 3 screw lizards. That's what it says. It says here. 3 screw lizards. Got to make sure we get those lizards captured. I don't know what that means, but I'm not going to argue with the poor guy who had to translate this from whatever language it was originally written in. But we're laying this down flat, like so. And we're taking the circuit board, and we're going to get a smaller screwdriver. Put these wires in here. And I'm going to tug on these because these can sometimes be not great. Also, there's a lot of wire showing through outside of the thing, so in an abundance of caution, I'm going to take some electrical tape and add a little bit of tape between them so that no electricity decides to jump the air gap. Okay. Well, that's the contraption so far. Very, 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 very professional looking, isn't it? I gotta tilt this camera a little bit, so hold on. There we go. And we've got the screw lizards tight. Now, the positive electrode, thick red wire, which is this, and the negative electrode, thin black wire, or in this case thin red wire, of the high voltage package are respectively connected to the screw fixing the copper wires. So that's why I'm back to here. Now I'm going to have to strip this. I don't think my Nipexes can handle this. Though I'll give them a try. They're pretty good. It's biting in, but it's not able to pull. And I don't want to damage the jaws. So, if I can remember, there it is. I'll take my X-Acto knife again and try and cut this. Okay, hopefully that'll be enough. So let's bring this back in. Get some of this insulation off the workbench. Now I'm gonna... Yeah, that's not enough. That's definitely not enough. I'm sorry folks, I'm gonna have to do this some other way. So I'm gonna turn off the cameras again and get that sorted out. I think I've got enough here now. It's a pain because as I cut the insulation off, I'm also breaking strands of wire off. So I'm going to have to bend this a little bit so it hooks around. And again, tight that down really well. I think that'll be okay. I hope so. We shall see. Other lead on. As you can see, it's not necessarily the most sophisticated piece of electronics I've ever built. Very 1920s, 30s feel to it, isn't it? I'm going to cut some more insulation off this. Give it a twist. So let's get the wires up and around. I'm going to take this antenna and bring it up this antenna and bring it up, and we don't want a very big gap at the bottom because that's where the arc will strike. So we'll bend that out a little bit, make sure these guys are facing each other and parallel as much as you can, and then I'll bend the wires out a little bit. As you can see there, I hope I've got probably 1/4 inch, 3 or 4 millimeters, and then they rise up, and again I want to make sure they're straight and somewhat parallel with each other. They're way too long for what I'm doing. I'm going to back this off a little bit. So that is the stuff you get in the box. Oh, my antennae are not the same width, so I'll trim one piece of wire off there. So that's that part of it. Now the next part, I'm going to go put this over on the other workbench where I'm going to fire this off. I'll be back in a second. No, I won't. Never mind. I'm not going to do that right now because it's all going to be wired together. The next thing to do is to hook up the power supply. Grab a random power cable that I have lying around. This came from a Bose subwoofer, so it should be dandy. Should I keep that? Sure. You never know. And again, we gotta strip the outer casing off of this. As you can see, the hard part of this project is stripping all the wire. And put it here. Now put the black wire in. Now the next thing we're going to do, we're going to set this to 24 volts because that's what this little beast takes. So I'm going to set up our meter. I'm going to plug this in, and again I've got to caution everybody, those are two 110 volt leads with no covers on them, and they are dangerous. So we got a green LED, and we've got a trimmer switch here to set the voltage. So let's see what we've got to start. We're at 24.15. Well, I'm not going to try and do better than that. Now let me unplug this so I don't make any horrible mistakes. And again, watch, see that you saw the LED, it faded out. There's some capacitors in here. Consider these wires currently hot. I mean, those screw posts currently hot because they may still have capacitance being held in them. Now the next thing I'm going to do is get some wire to hook it up to there, and I'm going to use some 16 gauge. That should be enough. That's the red. Trying to find the end of the black. There it is. There's the black. And I will strip these appropriately. 16 gauge should be plenty enough to handle the current. So this is 24 volts at, I don't know, 6 amps, something like that, whatever I forget the exact value. You can figure it out because the wattage on this power supply is 153 watts. The instructions for this kit say, or the specifications for the kit say it should be 24 volts, 150 watts, so we're about 3 watts over their specification. And again, I will put a link to this power supply, which costs like 23 bucks, in the description. If I don't, write a comment to tell me that I forgot again, and I will put it in there. So that's the negative. And on this one, it says circuit board. It's marked, fortunately. Negative on this side, positive on that side. Hope I can get the 16 gauge wire in there. I'm sure I can. So now it's time to be brave and turn this thing on. I'm not going to do it on my regular workbench. In fact, I'm going to do it out in my driveway. So I'm going to turn off the cameras and move some stuff around. So there we are on my workmate on my driveway. It's dark, but I've got a little light bleeding out from the garage, and this camera is too good at low level. So it still looks bright. Now I'm going to plug this in. We will see what happens. It's maybe something, maybe nothing, maybe a fire. I don't know. Now I'm going to turn it on. Ah, look at that. Let me zoom in. We've got an arc. And there it goes climbing. Oh, that's pretty neat. Oh, look at that. It's actually working. Look at that go. I mean, you can see it also burning the I'm going to try and turn this light off again. I can't get it. There we go. So now it's down a little bit. I don't know why it was going. Now it's going again. I think I'm seeing something. But it is actually working. I'm going to get a couple of things. I'm going to let you watch that for a second. And then now I don't know why it's not going as far up this time, but I'm going to do a little experimentation here. I suspect I put some rubber gloves on, and this is an insulated. There we go. There we go. Wow, when I get close to it, I'm going to steer this apart a little bit. There, look at that arc. That's pretty neat, isn't it? Now, look, that's a lot of plasma. Gosh. Look at her go. I mean, you can hear it. I'm going to set the microphone down. I hope it won't interfere with it too much with the Bluetooth signal, but we'll see. and you can see a bright spark. This is an insulated piece of plastic, by the way. You can see a bright spark on the copper where the arc is originating. That's pretty neat, isn't it? Let me grab my mic back, because I don't know if you could hear that. But there it goes, dancing along. I'm going to zoom in even closer so maybe you can get a better view of this. Oops, it's focusing on the concrete. Let me do some manual focus here. Let's get it to rise again. When I get close to it, there's some capacitance happening here. There we go. That's pretty outstanding, isn't it? So it definitely works. I think if I had a better connection at those two terminals coming off the coil, it might work better, but it works just fine. I mean, I'm happy with this. I wonder if I cut the wires down if it would go, but I'm not going to try and do that. Not right now. So there you go. I mean, it was a quick build, no soldering. You just have to have some wire and external power supply and that kind of stuff. And you can get a good arc going. So that is a Jacob's ladder. And again, the hardest part was cutting the insulation on this cable. So I hope you enjoyed this video. Again, if you get this, be very careful. This is dangerous high voltage. But it's fun and instructive in the end. And I hope you enjoyed the video.